right, so it's recording. So let's take a look at the virtual machine. So I'm going to go to the folder, just don't have that code on. So we were talking about stream ciphers, right? That was the last topic. I believe one of the last topics that we looked at on Tuesday. And we were saying basically we gave a definition, as all of these have, that we're basically sending data on a per byte basis, right? So we have the plain text and we send that on a per byte basis. And then we also send the key, right, on a per byte basis. So the motivation that we gave was that we go back to Claude Shannon and the OTP, right? And remember, Claude Shannon said, if the key is as long as the message and it is random, that means like really random, then you can achieve perfect secrecy, right? We're going based on that. And so the stream cipher is basically an attempt at creating the OTP, all right? So in a sense, so we talked about how we have a function called a pseudo-random generator, and it's basically an algorithm, and the algorithm generates things, basically bytes or information in general, and they're part of what would be a key that is as long, you would have the goal of it being as long as the message itself. However, that's not exactly achievable because we are using a function. The pseudo-random generator is a function, right? And so it is not random, it is actually deterministic, right? And as everything in the computer that is random is actually pseudo-random, okay? And so we're not achieving it, but it's like it can be good enough, all right? However, it can be broken. And so these functions just kind of have like two, so they have limitations basically. And one of them is that the algorithm is able to produce numbers in a sequence up to a certain point. So they have a period. What that means is it gets to a certain length and then it repeats again. Okay, it can't continue forever. And so really you want to make that period as long as possible, right? So that, because otherwise, if it repeats, then now there's a pattern in the data and it's not random anymore, obviously, by definition. Do you guys see that? And so it would be insecure. It starts to become insecure. Okay, so we're going to start to motivate this. Now, I'm not going to go into the algorithm. Instead, I'm just going to use some functions in Python to kind of generate the stream cipher. Okay, so the pseudo-random function generator is what we're going to implement. And from there, you guys could build your own algorithm if you wanted to. But I'm just going to go into that. We're not going to go into the algorithm that generates this sequence of bytes. And the reason for that is there's no point in it because anything that we do is insecure, right? So the one that is used for in Python, for instance, etc., it's insecure. Okay, so it's not actually good for cryptographic purposes. It's actually very difficult to achieve that randomness that you need in the stream ciphers. Okay, so but we're going to take a look at it just to kind of feel for it, but just be aware, it's a challenging thing to do. Okay, and so so we're going to take a look. So we're going to start with the script is short actually. So let's go ahead and let's open up and I think I already wrote this code on this VM, so I'm going to create a new one. So let's navigate to the desktop. So I said some of the functions that we use in this class are somewhat secure. This one is okay. So just be aware of it. All right. It's actually a very difficult problem. Yeah, so I wrote it in here. So let's just create a folder instead. I'm going to call it pseudo random number generator. Remember, that's really what we're looking at is that function. All right, and we're gonna use it just to see how it would work to motivate. So let's navigate in there. Okay. All right, so now, okay, so let's go ahead now. You're gonna need to do a few things. I already did this, but do pip install numpy. Okay, please go ahead and just pip install numpy here. And it's a library. You shouldn't get any errors. I wouldn't think. I already did it. You got an error.
Yeah, it says pip is not.
Pip 3? It's not. Oh, because you guys don't have Anaconda, right? Try pip 3. Does pip 3 work? Yeah. So this is the class I use in 372 and it's got the 372 settings. When you guys take 372, you'll have that little base there. All right, so hopefully that worked, right? Pip 3. And then also try then, okay, so hopefully this one will work too. I didn't test it on pip 3. The other library that we would need is something called random gen. Huh? That works too? Yeah. Okay, perfect. So that, and with pip 3? Yep. Okay, great. Yeah. So try that one. That's the thing that we're going to leverage that has the pseudo random number generator. Okay. That's basically what we're going to be leveraging. There's two. One is called Cha-Cha and the other one's called the AES counter. So we're going to use the AES counter basically. This is based on an algorithm. However, I'm not going to go over the algorithm in this course. All right. So let's go ahead. So hopefully this is installed now, and let's then just write the code. And then once we see kind of how the code works, we can think of how this would go, okay? So the key thing is we need to generate a sequence of random numbers, right? That's the idea with a pseudo random number generator. It's a sequence of numbers. And then those numbers would be XORed with the plain text message as they're moving, right? They're being encrypted, and the sequence has to be consistent both on the encryption and the decryption, right? Because it's happening on a per byte basis. So let's go ahead and write the code. So let's say pseudo random number generator example .py. Okay. So, all right. So now we would invoke the libraries. So I'm going to do from numpy. Yeah, I'm going to need generator from numpy.random. So from numpy.random import generator. Okay. So it's like this is the generator of values of sequences, and then we're going to tell it which algorithm we want to actually use, which implementation. So there's a couple. I'll provide both, but we will just use one. So from random gen, we're going to import this one, Cha-Cha, which is something you might, if you dig deeper into this, you'll come across this. It'll be widely referenced. And then you can also do from random gen import AES counter. Notice the C is uppercase here. Okay, so with these libraries, we're going to basically try to implement the random number generator. So now we're going to initialize it, basically the object. So we're going to say RG is going to be equal to generator, then open parentheses, close parentheses. And then inside, we're going to specify that we want to use the AES counter algorithm. So AES counter. And here is where you provide a couple of things. So you provide the mode just to indicate that you want a sequence. The mode equal sequence uppercase S. like that. Right, so this allows us to generate our sequence that it should be something that we can replicate the next time that we use it, as long as we provide a seed. All right, so in this case, 1, 2, 3, 4, 5. So this is the thing that would be random, right? So don't forget that in this kind of a technique, this is the thing that should be random, and the rest is a deterministic algorithm. Make sense? All right, so once we've defined this part, I mean, as I said, this is not very long. We can do print RG just to kind of look at this object, see what's in it. It's an object for the generator. And then after that, we're going to proceed to just generate the sequence. All right, and the sequence is just numbers. And from there, we can convert it to byte arrays, etc., hex, or whatever we want. But the key is that we're getting random numbers. Right, so you'll see how this can be done. So let's say, for instance, I'm going to do 10. So for I in range, and then I'm just going to say 10, right? So that's 10 like that. And then colon, and then now 1, 2, 3, 4. I'm going to just generate them. So I'm just using some variable res, for instance, and I'm going to invoke RG, which is the object. Okay, now to be more specific, maybe you should have called RG PRNG, right? If that helps you, you can go ahead and do that. And then RG now will generate random. Okay, and that's it. So now this just generates a fraction, right? So I'll show you in a second how we can simply manipulate it, right? And so then the next step is to print res. Okay, just like that. Oh, and also, oh yeah, let's just leave it like that for now. Okay, so let's go ahead and try it out. Hopefully it'll work. So I think you guys have to use Python 3, possibly. Should work. Oh yeah. Go ahead and try it out and let me know if you get an error. Does it work for you guys? Do you get this? Yep. All right, perfect. So what's happening here is you're getting some decimal values. Now let's run it again, right? So that's the key. And what do you notice between one sequence and the next sequence? Yes. Yours is not working? How about for other people? Is it working for? Okay, so it's probably a typo. We'll take a look at it in a second. But what do you guys notice in the data that's being generated?
So it's the
Same, right? And that's what you need to happen, right? As long as you have the deterministic algorithm and you have the seed, which is the same, then on the encryption and the decryption side, it's generating the same sequence of random numbers. And that's the key, because from here, then you can use those values to generate, you know, the bit sequence that you would then use to XOR with the plain text message. And as long as it's consistent, you should be good to go. Does this make sense, guys? Make sense? So for instance, if you don't want the decimals, we can convert it to integer. So we're going to go back to the code. Okay, I can run it again. So I ran this several times, so you can see it's still the same value. And this is what matters, okay? So that you can do it. So now let's just convert it to integer just so I can show you. So for those of you that were having an error, can you double check your code? It's not generating what you. Yeah, you're printing RG. Not look. Are you doing this RG.random?
Oh my God, it's exactly like this.
Really?
There is, I do have a space in between, four and res. There's like a, an empty line. Does that matter?
Shouldn't. I'll take a look in a second. Let me just kind of complete the code and then I'll go around and see what's going on. All right, so the last thing I wanted to show you is this actually generates decimal values. So we can change that to integer values, for instance, that align better with the ASCII table, for instance, right? So you can go in, if you make these, like, you know, all you have to do is multiply these decimals times some number. So for instance, you can multiply it times 100. You see that? And then choose to make it an integer. You know, like I'm going to add res equal int res, just like that. And then when you run the code again, clear here, you can see it gives you now a sequence of integers. If you run it again, 59, 49, 23, 64, 61, 92, 62, 22, 15, 71. And you guys already know at the ASCII table, right, how to convert back to the decimals and hexadecimals. So we can basically implement or tie this to the XOR algorithm, or sorry, the XOR operation that we had done before, so that you guys can XOR the message. Does this make sense, guys? Is this clear? You guys see the idea, right? All right, so you can run it again. You can see, and basically that's the key thing, is you always get the number and it can be converted into the binary and XORed with your message. And this is much shorter than a block, right? You can think of it as just one byte. Got it? All right, so I'll bring up, I guess I'll pause the video here, and then I'll bring up the code.